So as a heads up for today, just disclaimer, this is like your fine print. We're gonna do a little bit of writing, okay? So hope you're ready to write a little bit. It should still probably be less than what you write in English class, though. But we're gonna do a lot of justifications today. And the way I teach this is I just drill it into everybody. So when you see that word justify, it's not gonna worry you because we've just done it so many times. You got me? I'm gonna send you in there ready. Okay. So critical points. We've gone over this before, but it's a big topic here in the lesson we're going to do. So we're going to bring it up again. It is where your derivative is 0 or undefined. People forget about that undefined sometimes. It's where your derivative is 0 or undefined. So like if you had a sharp edge or something, that's a critical point. And those are your candidates for locations of relative extrema. I abbreviated relative REL, relative extrema. That's just the plural way of saying relative maximums and minimums, relative extremes, okay? They are the candidates. That means that they may or may not be, but they're the candidates for locations of. The most common mistake I get is people get the critical point. Give me a number, I don't care. 7. Okay. They get that the critical point is 7, and they'll say the relative maximum is 7. The relative maximum is located at x equals 7. So you have to be very careful because it is wrong the other way, and they will mark it wrong. Okay. Now, also, what we're going to do is called the first derivative test. And one year we're taking a test. No, the topic we're covering is called the first derivative test. It's a test that you use the first derivative for. Are you with me? It's not, you're not getting a test. Okay. So first derivative test. If f of x changes from positive to negative, that is a location of a relative maximum. And I'm going to let that sink in. Positive to negative. If your derivative is positive, remember Alice going for a walk. If your derivative is positive, what does that mean your graph is doing? If f prime is positive, what does it mean f of x is doing? Increasing. Positive to negative means that the graph changed from increasing to decreasing. Do you see why that would be where you end up with a maximum, a relative maximum? All right. And then I call this the sibling statement. You can probably write it without me really saying much. It's going to be the same thing, but the other way around. If f of x changes from negative to positive, then that is the location of a relative minimum. But you can end up with critical points that don't give you either. And they like to do that to you as well. And you would say neither because blah, blah, blah. And I'm about ready to teach you how to write out all of your justifications. And I put this f of x, f prime. We've gone over this before, but again, it's good to repeat. Increasing positive, decreasing negative. That's like you're above and below sea level. This little thing right here, we're going to add on to it next time. And what I do is I give everyone a sticky note, and you're going to keep your sticky note with you. And I call them the sticky note problems. And everyone's like, oh, sticky note problems. And you just kind of like look at that to answer all of your questions. But for right now, we're going to leave it because we're going to add on to it next time. But increasing positive, decreasing negative. That's all the notes. We're going to just apply it. So we're going to find our intervals of increasing and decreasing and the relative extrema. There's your relative maximums and minimums. Justify. I know that's a scary word, but it shouldn't be by the time you leave here because I'm just going to drill it into you and you're going to be just fine. That means write a sentence. A sentence should have the word because in it. All right. So the first thing you find is your critical points. You're going to get your derivative, set it equal to 0. All of these are going to be derivative equals 0. That's how you start. So what is our derivative? 3x squared? Good. Plus 6x. We're going to set it equal to 0. And then we're going to do some algebra. So what would you do next? Factor out 3x. Good. That would leave you with x plus 2. So your critical points are 0 and -2. Those are critical points, whether they give us relative maximums or minimums or not. They still count as critical points. I'm bringing up because there's another thing that's a little different. So I'd like to stress that. So those are critical points no matter what. Now we make our number lines. And when you do your delta math today, you're just going to draw number lines. That's what your board is going to be filled with. So 3x, that gave us the critical point 0. X plus 2 gave us the -2. Do you see how I put them in order, smallest to biggest? How number lines work. And if you were with me in pre-calc, this is how I explained it. If nothing weird happened, meaning nothing is squared or backwards, or there's not an extra negative floating around, like if something weird happens, you're gonna be like, huh, that's weird. If nothing weird happened, how can you fill in your number line? Yeah, negative to positive. If that doesn't suit you, if you're like, I didn't like that, pick a test number to plug in and see if it comes out positive or negative. All right, I'm going to draw my little balloon strings. We've done this in here before though, didn't we? With velocity acceleration. I call them balloon strings. What is your overall sign for the first section? Positive, and then this is negative and positive. So again, if nothing weird happened, it's going to alternate. Now we're going to write some sentences. Your sentence should start with f of x is or f of x has. F of x is the subject of your sentence, all right? So it should start out f of x is or f of x has. We're going to do our increasing and decreasing first. So f of x is increasing. Look at your number line. Where do you think? If you had to guess, use your common sense because it does make sense. On what intervals would f of x be increasing? Negative infinity to -2. Union, yep, 0 to positive infinity. Because, so the way I always teach this is f of x is the subject of your sentence, but f prime is your source that you're citing. You know how in English you have to do like a works cited and cite your bibliography or whatever? F prime is the guy that you're citing, all right? So it's because f prime is positive there. So your sentence should start f of x is or f of x has. And when you do the because, your source that you're citing is f prime. He's the guy that's like giving you the information. That's why it's called the first derivative test, is you're citing your first derivative. Now I call this the sibling statement. It's going to be f of x is decreasing everywhere else for the opposite reason, right? So decreasing where? Yeah, -2 to 0 because f prime is negative there. That's how you do these justifications. They turn out the same every time. Like I can't change this. On your test, those are the answers. The numbers might change, but that's how you write the sentence. All right, now we're going to do the maximums and minimums. So this is going to be f of x has a relative maximum at x equals what? I told you were going to write a lot. I heard the mumbling back there. I warned you. I told you what the fine print was. Now, do you think the maximum is going to be at -2 or 0? It's one or the other. Good, -2. Relative maximum at x equals -2 because, who's our source we're citing? First derivative. F prime changes from what to what at -2? Changes from positive to negative. A positive to negative means the graph went up and then down. That's why you get a relative maximum. Changes from positive to negative there. And then you're going to do the sibling sentence. F of x has, if you start out f of x has, you won't mess up that location of. Bless you. F of x has a relative minimum where? At x equals 0, because f prime, good, that's your source you're citing, f prime changes from negative to positive there. If you have a change from negative to positive, that means f of x changed from decreasing to increasing. So you end up with a low point. We'll do number 2 and then I'll do your halfway break. Well, we're going to repeat that process. Okay, so for this one, we're going to repeat the process, but we don't have to find a derivative and do number lines and all of that stuff because we were given a graph. So we're going to repeat all this, but we don't have to do this work. That makes sense? Because we have the graph. Now, is that the graph of f or f prime? Prime. Are they going to ask you questions about f prime? Now, they're going to ask you questions about f of x, the one that you're not looking at. Do you get what I'm saying? Are you okay? Okay, I'm just checking because you look a little not well. It's f prime. I'm sorry. It's supposed to be first derivative. This is first derivative test. It's supposed to say first derivative. I'm sorry. Okay. But this is your first derivative. So let's write our first sentence. F of x is, you're talking about a graph that you're not looking at. This is your source that you're citing, but you're talking about a graph that is not this graph. All right. F of x is increasing. Where do you think? I'm going to let you guys guess before I just tell you the answer. Where do you think? Good. 0 to 2. That's this right here. Union, where else? 4. Now, you can stop at 7 and union on, but you don't have to. And I think it's less work if you don't. You can just go ahead and say 4 to infinity. Yeah. All right. Because what's the reason? Who's your source that you're citing? Derivative is positive there. Well, I fit mine all on one line, so I might be able to make this work. Above sea level. Here, I'll highlight it. Looks like a little sea serpent. All right, sibling sentence. F of x is what? Yeah, decreasing everywhere else for the opposite reason. Okay, but what are we going to say? Decreasing. Yeah, negative infinity to 0, good, union 2 to 4, because why? F prime is negative there. When it says justify, it's not going to scare you because I just drill it. We just write all the sentences every time and you're just going to be able to write them all out. All right, now we're going to do the relative extrema. You have to mention every single critical point. So we have a bunch of them. Do you see all these here? How many critical points have we got? 4. Now, I think we're only going to have to write 3 sentences, though, if I'm remembering this from last year. F of x has a relative maximum at x equals where? A maximum would be a change from what to what? Positive to negative. So where do you see that happening on here? Do you see how at 2, it goes from positive to negative? Above sea level to below sea level? Relative maximum at x equals 2, because I will not be able to fit this all on the same line. Who's our source? F prime, because F prime does what? Changes from positive to negative there. And please write positive POS and negative NEG. I don't think that they will take a plus sign and a minus sign. I would not mark it wrong, but they will. So practice the way you're going to do it on the AP exam. All right, sibling sentence. F of x has a relative minimum at x equals, where do you think? There's actually 2 of them. Yeah, do you see how at 0 and 4 we go from below to above? This is how we're going to get away with only writing 3 sentences instead of 4, because you have to mention all the critical points. Relative minimum at x equals 0 and x equals 4, because why? Good. F of x changes from negative to positive there. And you have to write one more sentence. Who is the critical point that we did not mention yet? Because you have to mention all of them. 6. Now, there's not a change at 6. So it's still a critical point, but you don't get a relative maximum or minimum out of it. Do you get what I'm saying? Okay. So f of x has neither a relative max or min at x equals 6. I know you're like, we hate you, Miss Cole. You won't hate me when you get it right on your AP exam because I drilled it into you. What's that?
7.
Oh, 7? Sorry, somebody said 6 and I just believe you. 7, thank you. Crisis averted, thank you. F of x has neither a relative maximum or minimum at x equals 7 because, who's your source? Yep, derivative. Now, there's a couple different ways you can say this. Here's how I suggest you do it. It's the same as you did all these other ones. This says changes from positive to negative. This says changes from negative to positive. I would say because f prime doesn't change sign there. I get some people that are like, want to say stays positive there. Do you see how this stays above sea level? Here's why I recommend against that. What if it's below sea level? Then your answer would be because F prime stays negative there. I like methods that work 100% of the time. So if you do this, it won't matter. You'll get it right. Do you get what I'm saying? Like, so that's why I prefer that. But if you said stays positive there for this problem, then that's correct. Cool. All right, so this one does not say find the relative extrema. What does it say? Find the absolute extrema. So when it says absolute, that is what's called the candidates test. And your candidates are your endpoints and your critical points. So your candidates are endpoints and critical points. This is the theorem from last time that we didn't really do anything with, and I said we will next time. Do you remember, like in the warm-ups today, we did intermediate value theorem, we did Rolle's theorem, and we did mean value theorem. Do you remember how there was a fourth one? It's your extreme value theorem. That's what this theorem is that you have to have an extreme, a maximum or minimum, either within the interval, that would be one of your critical points, or on one of the endpoints, okay? So first we're gonna find our critical points. How on earth do we do that? Derivative, good, equals 0. Good, perfect. Derivative equals 0. So this derivative will be 12x squared plus 6x minus 6. I'm going to do some algebra. What do you notice about all this? Because I'd like to make the numbers smaller. Yeah, they'll all divide by 6. So it's kind of like reducing a fraction. Just easier to deal with smaller numbers. 0 divided by 6 is still 0, so that part doesn't change. And then we're going to factor. It is mostly algebra. The only step that was calculus is finding the derivative. All right, and we will need, what, a minus and a plus? 2 minus 1. All right, so what are our critical points here? Yep, -1 and 1/2. Now, are those both on the interval? If they're not on the interval, we get to toss them out, which is great because it's less work. I think they're both on the interval. So here's what you do. You set up a table, and it's not the derivative. It's the original function, which that can get messy sometimes. I'm going to try and get us through it without a calculator, but if I get to a point where it gets too messy, I'm going to bring up Desmos. Same thing on your delta math. Please use your common sense. If it seems easy enough, I want you to try. If it seems ridiculous, please type it in the calculator. Right? So I like to put these in order because I'm very type A. It really doesn't matter what order you put these on here, but our candidates are these endpoints and these critical points. So I like to put them smallest to biggest. Again, you do you. And again, those get plugged into the original one. So let's just see how far we can get. -2 cubed. -8 times 4, -32. I'm just going to like write myself a little dyslexic moment. -32. I'm just doing like a margin problem. All right. -2 squared. 4 times 3 is 12. Good job. All right. And then plus 12. So 12 plus 12 is 24. -8. Cool. So like that would be reasonable to do without a calculator. All right. -1 cubed would be -1 times 4 be 4. Plus 3 plus 6. Or did I do that wrong? -4. I even said that and didn't write the negative. I said it out loud and then did not write it. Okay, so that would be 5. I'm going to come back to that 1/2. All right, if you plug in 1, you're going to have 4 plus 3 minus 6, which would be 1. Let's just see how far we get. I don't know. 1/2 isn't a bad number. If it was like 3/7, I'd go to the calculator right away. But let's see what we can do with a 1/2. 1/2 cubed. 1/8 times 4 would be 4/8, which is 1/2. Okay, there, we're still good. 1/2 squared, 1/4, so that'd be 3/4. And then 1/2 of 6 would be 3. Oh, that's not too bad. We can do that. What's your common denominator? 4. So we would have 2/4 plus 3/4 minus, how many fourths would be a whole 3? 12. Good. It is good for you to do that. Sometimes it's like eating your green vegetables. You know what I mean? It's like good for your brain.
Sorry, this is like.
Yeah, you're fine. Oh, those were the endpoints. And then these are our critical points. It really is a bummer when you have like a list of critical points. That happens sometimes, and you end up having like 6 candidates on your table. 4 is not so bad, but sometimes it gets a little messy. All right, so what is that? -7/4, which in decimal form would be like -1.75, like -1 and a little bit. Anyway, now we write out our answer. Your absolute maximum is which one of these numbers? What is the biggest number that we got? 5. At x equals -1. No, and I'll explain why in a second. And then your absolute minimum is, which is the lowest number we got. The lowest result. Yeah, -8, good. At x equals -2. That's your answer. And it says justify. Here's the really good news. The chart is your justification because you tested all the candidates and you showed what they came out to. So the chart is the justification, which is nice for them. So that's the candidates test. Candidates test is for absolute maximums and minimums. All right, last one. Get your derivative, set it equal to 0. So what is our derivative? -2x minus 4. You get -2. Now the directions are the same. I didn't change the directions. We need to find the absolute maximum and minimum. But what did you not get on this problem? Yeah, you don't have, what do we call this? Yeah, you don't have endpoint. You don't have an interval, okay? Now, when this happens, and they do this sometimes, if you don't have an interval to live on, you have to show that you have considered the entire number line. And you can't sit there and test every single number forever. Numbers are infinite. So here's how you do it. You make your number line. Now, it's -2x minus 4. Do you see that there? Huh, that's weird. There's a negative out front. Instead of putting in our number lines negatives and then turn positive, it's going to be positive and turn negative. But if you're like, hey, that confused me, Miss Cole, let me show you. Give me a number on this side of -2. -3. If you plug in -3, you're going to get 6 minus 4, which is a positive number. Do you see what I'm saying? If you pick a number over here, it's going to end up being negative. So this graph increases and then decreases. So do we get an absolute maximum at that point? Yes. It's a little wordier how you have to say it, though, because you have to show that you thought about every number ever on the entire number line. So here's how we say it. We have an absolute max is, the absolute maximum is not -2. How could we get what the absolute maximum is? Because this is just where it's located. You have to plug it in. Good, just like we did on this table. So if you plug in -2, what is that? -4 plus 8 would be 4 minus 7, -3. If you take -2 and plug it in. Did anyone else do that in their head and verify? All right, then I'll talk you through it. -2 squared. 4, but it's going to be -4. This will be plus 8 minus 7. Did I do that right? -3. Because that's just the location of the maximum, not what it actually is.
That's what we've done before.
Yeah, it's exactly what you did before. So the absolute maximum is -3 at x equals -2 because, now, why is it absolutely the highest? But why not some other number? Like, why does it have to be this one? It's the only one that there is, and that's how you say it. Because -2 is the only critical point. That's how you say it. If it's the only one, it has to be it, right? Because -2 is the only critical point, and who's our source that we cite? F prime. It's the first derivative test is why it's called that. F prime is positive where? We made a number line. Just on what interval is F prime positive? 2. And F prime is negative where? And so by doing this, do you see how we showed that we thought about the entire number line, negative infinity to positive infinity? That's how you justify that. However, I will say I've seen this. That's why I put it in the notes. So did I teach it to you? Yes. Most of the time, they give you an interval and you just make a little table and test your endpoints and your critical points, is how that works the majority of the time. Okay.